We're going to move now to the second page of the notes. As you can see, the problems are already there for you. We're going to go through, we're going to analyze the information given, and we're going to write a 2-column proof. As you can see in the notes, it says, determine which of the theorems is demonstrated, meaning is it side, side, side? Is it angle, angle, side? Which one is it? Make sure it actually does imply congruence, meaning it's not angle, 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 or side, side angle. Those ones don't even imply congruence. And then write your 2-column proof in that order. By that I mean, if you have side, angle, side, I want you to start with the side, then go an angle, then go a side. I want you to be giving it in the same order as the theorem you're going to use. And then you're going to end with a congruent statement, meaning you're going to end with this triangle is equal to this triangle. And if they're trying to prove something else, you're going to use CTCP. Okay, so here's the first example, and you're going to have to add a couple of lines to your problem. So add your lines. You can see I've added 2 pairs of sides that are the same and an angle that's the same. As you can also see, we have x and y there. So the point of this thing might just be to say, all right, prove to me that x is the same as y. So as you can see on the notes, we have a statement and a reason column. You're going to have to write this for everyone after the first one. Your first step is to look at the picture and decide which of the congruence theorems is it. One of the easiest ways to do this, is to identify what they gave you. They gave you a side, they gave you another side, and they gave you an angle. Okay, which of the possible things could it be? Well, it could only be side, angle, side, or side, side, angle. Side, side, angle doesn't even work, so let's double check that in fact, as it says in step 2, make sure it actually is congruent. So in this case, as you can see, the angle is in between, it's connecting. So that angle is the connector for the two sides that we know. So because of that, we know it's side, angle, side. Now all we have to do is list it out. So I'm going to start with the first one. AB, okay, meaning this piece right here, is congruent to EF. Notice that I started at the part, when I said AB, I started with A, which is next to the letter, and I went to B, which has the angle in it. Here I started with the letter E and went to F, where it has the angle in it. So it's important to notice that you try to use the same order if at all possible. Okay, the reason for that is the problem gave it to you, so you just put simply given. Okay, the problems will usually give you information, and you want to start off with given if possible. Next, we were given that the angles are the same. You can do that as angle ABC, or you can write it as angle B. In this case, I went ahead and did B and F, and again, that's given. Notice so far, I have done in the order of side and then angle. Lastly, I will do side, and the reason then, later, I'll be able to say my reason is side, angle, side, and to a person reading it, they can follow straight down the list. Okay, I see a side, okay, I see an angle, okay, I see another side. Last one, BC is congruent to FD. Again, starting at the angle part B, going towards C, unlabeled. Same for the other one. And again, it's just given. Now we have listed a side, an angle, and a side. So we can now say because these two triangles share sides and an angle in between, therefore the triangles themselves are equal. ABC is the same as EFD. Notice again, I went in the same order. I started with A, then I went to the B, which has the angle, then I went to C. So this time I went E, which has X, F, which has the angle, and D, which is by itself. So we're trying to make sure that the order you stay the same, even if the letters are out of order alphabetically. This is not a given. This is proven by you because of side, angle, side. We now know that every time two triangles have two sides with an angle in between, those triangles are congruent. That's what the theorem says. So therefore, we can say they're congruent. If the problem is asking you for a bit more information, so for example, if on this problem I said, hey, I want you to prove that x is congruent to y, angle x and angle y. Well, now the way you prove that is you simply go one step further. You say, okay, angle x is congruent to angle y because CTPC, meaning once we know the triangles are the same triangle, Well, if they're the same, they must have parts that are the same, those parts being the angles. Okay, moving on to the second example, you're going to have a little bit more to label here. Okay, so hopefully you did that. If not, you can feel free to pause it some more. So now in this case, we have two angles and we have one side. So that limits it down to angle, angle, side, or angle, side, angle. You just have to figure out which one. So to do that, I'm going to look at the order. And I'm going to notice that my angle and my angle are next to each other, but the side is off by itself, which tells me it is angle, angle, side. So I'm going to go ahead and start my proof. And I'm going to simply say, okay, I've got angle OYW, or you could call it angle Y, is congruent to GKW. Again, you call that angle angle K. Those are congruent because it was given. The problem gave them to you. Okay, next thing up, we have angle, angle, side, so I want to do the next angle. And again, it was given in the problem. Lastly is the side. Those are the two that are equal, and again, it's a given. This one's not asking you to prove anything extra, so you're simply going to make a congruent statement about the triangles and use your reason of angle, angle, side. Moving on to number 3. This one looks a little bit different. So go ahead and do your labels. As you can see, the problem here is we don't have three things. We have two sides. A lot of times what people don't realize is when two triangles are connected like this end to end, the whole purpose of that is to say, but wait a second. If I separate these triangles, this side right here is going to be used for both the triangles. Well, if it's the same on both the triangles, then it's a third side. So now what we have is we have two triangles that have three sides in common, which fits the requirement for side, side, side. So we're going to go ahead and start listing it. Once we decided side, 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 we're going to go ahead and start with one of the sides, which is given to us. Go on to the next side, which is also given. And when we want to say that RT, it gets a little bit confusing because you're like, how do I say RT is the same as RT? Well, you do exactly that. You say RT is the same as RT, and you have two ways to say it. You can either say it's a reflexive property, or you can also say it's a shared side on a triangle. For me, shared side will work because it shows me you know what you're talking about in terms of what's going on in the triangle, even if not the whole vocabulary of reflexive and substitution and all these different terms that are reasons why we do what we do. And then, of course, we end with a congruent statement of side, side, side. Okay, so the next thing we're going to do is we're going to be looking at page 3 of the notes, which has the last 3 examples. All right, so go ahead now and label the pieces that are given here. And think about whether or not you can write your triangle congruence proof. All right, so here's the deal. When we look at this one, we have two sides and an angle. However, if you look at it, it's really side, side, angle. Remember, that is the one that does not have triangle congruence. So if you tried to write a proof, here's your reminder. Don't do it until you've first done the first step, which is decide on it. Then which one it is. Second, is it even a congruency? Because this is why it's step 2. If it's not, you just simply say exactly what you see on the screen right now, which is not necessarily congruent. Okay, number 5, go ahead and label. All right, so here we're going to try to identify it again. As we look at it, you can see we have a side that's labeled. We have an angle that's on there as well. And we also have a shared side. If you're not seeing the shared side, right there is a shared side. Now we don't necessarily know that this angle here is 90. I mean, we do because they're supplementary, but it's not a given. We're going to have to comment on that when we go to do the problem. So as we go through it, that's what's going to happen. So think about maybe trying to write that and see where you go with it. Okay, so first thing I'm going to do is I'm going to start off with EH congruent to GH because that was given to me. Okay, then I'm going to go ahead and I need to share the angle. I'm going to say, all right, EHF is 90, and then therefore GHF must be the same because they're supplementary. Technically, you could go on and say, okay, GHH is 90, therefore they're congruent, and go into further depth. But the basic idea is we're using supplementary straight line angles to do this part. And then finally, FH is congruent to FH because of either reflexive property, or shared side. That then proves the triangles are congruent by side angle side. And if I want to then say, hey, is x equal to 8? Yes, it is, because congruent triangles have congruent parts. Okay, number 6 is going to look a little bit different. It's going to be more like what you might see in a lot of the textbooks, which is they don't necessarily label the picture for you. They're giving you the information you need, which is that C bisects segment AE, C is the midpoint of BD, prove that W and X are congruent angles. So once you need an angle that's not given, you're going to be knowing that you need to use CTCP. Okay. I did this like on purpose because the whole point for me is to introduce a couple of vocabulary words that you may or may not be familiar with. Bisect means cut in half. Midpoint means it's right in the middle, which also means cut in half. So they're very tricky ways of saying that this on each side of it are equal, and they do that very often. So what I might say is I'm going to say, okay, C bisects segment AE. Okay, so C bisects AE, therefore this is equal to this. Okay, C is the midpoint of BD, meaning BD is now broken up into 2 even parts. From there as well, you'll notice that you have vertical angles and you're left with side angle side. So as you then go through your proof, we're going to need to list out the things that are there. I'm going to do this proof with you. Okay, so taking the lines off of there. In order to prove this, it's a little bit tricky. Now that we know those things are equal, you're going to want to just say BC is congruent to CD and AC, and you can't quite do that though because those things aren't given in the problem. What we can do is say what's been given to us. Okay, what was given is that C bisects AE. That was the first thing that was given. Okay, the second thing that was given to us is that C is the midpoint of BD. Those things are given. Okay, if you're using the fact that it bisects to then say that things are equal, that's you that's doing it. So you need to list your reasoning. Okay, not that it was given, that's your reasoning. So from here, now I would say, okay, AC is congruent to EC. Well, how do I know that? Because it told me it's bisected, and that's the definition of bisect. It's what bisect means. It means cut in half. Okay, equal halves. Now I can say angle. ACB is congruent to ECD. Okay, how do I know that? Because they are vertical angles. Those are my 2 angles across the X. And then lastly, I can say, all right, BC is congruent to CD. Why is that true? It's true because of definition of midpoint. This time I said it's the middle. Each half of it is equal because it's middle cut into 2 equal halves again. Now that means side angle side, and I can lastly say congruent triangles, congruent parts. The big thing for me is making sure you guys understand when do I write things into my proof. It's not complicated. If something is given, you probably are going to have it somewhere in your proof. Okay, it should be in there no matter what. If something is given and you use that to get other information, so for example, if I knew that these lines were parallel, okay, well that might tell me something like this angle and this angle are alternate interior. Okay, well now I can use that to help me. But I'm the one that figured out the alternate interior, so that's going to be my reasoning. The parallel lines, that part would end up in my proof. Okay, because that was given to me by the problem. Down below this video, you'll find the homework assignment that goes with it. And you can go ahead and print it if you need to, or you have them in class as well. The problems are going to be done the same way. You're going to need to write your proof on a separate sheet of paper. And that's about it. So if you have any questions, bring them back with you to class.